Okay, hi everybody, welcome back. So today we're going to talk about hashing, which is going to be the basically chapter 27 of the book. Um, so the first question is why hashing, right? So we're going to answer that question. Hashing, so far with all the data structure that we learned, the array list and the tree data structure, the best we could do to find an element inside these data structures is order of log n, and that's if their tree is completely balanced or basically we have a particular conditions for us to be satisfied. Then we can, the best we can do is order of log n, but we'd like to do much better in order to find a data structure that do this a lot better than this for us. So we're looking for a data structure that can help us to search, insert, and delete data in order of one. And that's what we call hashing. So the hashing is going to be introduced in this chapter is like an array, and we store the data in the array, but we're storing in a limited size array. So we're going to do some techniques. So the data that we're storing inside we're using the hashing techniques, we call them map, basically. So we create a map or hash table or hash map, or also sometimes we call it a dictionary. And the data is going to be look like the basically always have two parts. They have key and they have value. The hashing is going to be this the functionality that we're going to give it the key, and the function is going to calculate the index for us. So that way, when we know the index and we're trying to just store element in a particular index or retrieve it from particular index, is only going to take us order of one. So that's the idea, that if how we can calculate the index every time, so we can do it as fast as possible, as fast as order of one. That's the idea behind the hashing. So have a limited size array and store the data by calculating the index every time using the key of that key element, and be able to basically retrieve and store data in order of one. So we can always think about it as a dictionary, like what you see here. The values are going to be the definition of the terms that you're looking for them in the dictionary. So how this works, right? So how we can do it as fast as possible in a limited size array. So the idea is calculating, as I said, the index. So this hash function is going to get the key and it's going to calculate the index. So that's going to be the location. If this is going to be look like, this is going to be your hash table. Usually hash functions are going to be a kind of a function that is using some sort of is helping us to first of all distribute elements inside the limited size array that we have, and it's going to use some sort of a prime number in it. And the prime numbers are the best because they help, they're not divided by any other numbers, so they're going to be a good candidate to giving us the best distribution. And the prime number that usually is going to be used is going to be the closest prime number to our size of the array. So here in the example, the array that we have is size 11. So the first element that we're trying to store, the key of it is 44. So we'll put it inside this hash function that we have. So this is going to be key mode n, and n is 11 because we have 11 elements here only, and 11 is a prime number, so that's going to be the best candidate. So 44 mode n is going to give us 0. So that means the index calculated 0, so we put 44 in the 0. The next element is going to have a key 4, so we put the key here in the method inside the function, hash function, and then it's going to be calculating the index for us, the index 4. Then the next element is going to be 16. So 16 mode 11 is going to return 5. So we put it in the index 5. And the last one is going, or not the last one, but the next one is 28 mode 11. The index come back 6. Next one is 21 mode in, and the index come back as 10. So far, so good. The only thing you kind of notice as we're getting, we're having more element, we're getting close to 50% full, then we see some kind of clustering of data. So there's some data here on the top, and then empty, and then some data in the middle, and then empty, and then some data at the end. So this clustering can create problem that we call it collision. So that create collision problem. And you can see now, we're trying to add 26. We're calculating 26 mode n, and it's going to return 4. And 4 is already taken. So the linear search probing algorithm is going to tell us, okay, if the collision happened and you'll not be able to add it into that index, the index is already full, you're going to put it in the next one. So you're going to do basically the whatever index is plus 1. If you couldn't find it, so that's also is full, so we're going to do that one more. So linearly, we keep going until we find an empty spot. So here, we have to do 3 times before we basically be able to find an empty spot for the 26. So 26 is going to be inserted in the index 7. So now you may question us, okay, how we're retrieving 26. Same exact approach is going to happen. So we're going to ask a hash function, passing 26 to it. It's going to return 4. Then we search inside 4, but it's not there. And then we go to the next one, and next one, and next one. And finally, we find 5 because we know we lose the linear probing. And so we have to linearly search for the 26. So not only clustering and collision is a problem, but also you can imagine that if you have a long list, long cluster here, then and we're almost close to the full, then for us to adding or retrieving this data is going to be it's going to take us almost close to order of n, right? So we have to keep linearly search for an empty spot. So that can be getting expensive for us, and not anymore order of 1. So because of that, the next type of clustering come to the picture, and that's a quadratic probing. So basically this telling us that instead of doing this linearly, why not basically change that, and we're going to look at by using the basically some sort of an index k to calculate that for us, right? So that means that whatever value of the hash is going to be, it's going to be calculated by the number of collision multiply, or sorry, number of collision power 2. So here we have our very first collision, which is 1. So we're going to do 1 power 2. So that's going to come back 1. So we're only going to do 1. And then 5 is already full, so that's going to become our second collision, right? The second collision happened because 5 is also full, so it's going to be 2 to the power of 2 this time, so which is going to be 4. So now we're going to add 4, the original index that came out of the hash, and we're going to do 4 plus 4. So that's going to be 8, and 8 is not full, so that's it. After 2 probing, basically now this time we can find. So it's going to give us a little bit better, as far as the number of time that you have to search, right? From 3, now we search back to 2 only. But still you see the same situation happen, right? So you still see the clustering. So as we get full, definitely going to get to the same kind of problem that we had with the linear. So the next kind of idea was, okay, you know what, instead of just having one hash function, why not we going to create 2 different hash functions? So if you have collision, we're using another hash function to try to kind of help us to get rid of that, basically. So the first basically our the first hash function here in this example is going to be the one that we already used. And the second hash function is this one. So 7 minus k mod 7 is going to be the second hash function we're going to use. So the example has changed in this one, I believe. So we added the 45 and into this in this array or this hash table. And so when we calculated the key for it using our original hash function, it's giving us 1. So we didn't have problem. We didn't have problem for 58, 4, 28, 21. And then now we're trying to add our next element into this basically list. And I'm trying to figure out what is the element that we're trying to enter. And I think that's 12, right? So key is 12. So they want to add 12 into the list. So they put 12 and then they do the calculation for the mode. So then they do the calculation for the original or actual hash function. The calculation come back as a 1 and the collision happened. So since the collision happened, we need to use a second function. So now we're going to find the hash, which is 1, right? The original hash result was 1 plus we're calculating the second hash and then we add them together and we're finding the index. So we need to put 12 now in this formula. When we put the 12 in this hash, second hash, the results come back as 2. So 2 plus 1 is going to give us 3, which is again another collision. So that didn't help. So what we have to do now next time, so we're going to add the number of collision multiplied to the second hash. So basically this is, if I is the number of collision, it's going to be the original hash plus I multiply the second hash, original hash plus I multiply the second hash, and I in this case is 2. So the original is going to be 1. The second hash give us 2. So we do 2 multiply 2, which is 4 plus 1. Now it's going to give us 5, and 5 is empty. So we can put 12 right there. So that is still not as good as we expected. So we still get to collision, right? So it's acting kind of like quadratic, but we added a second hash function and a lot of other things to it. We still do have those clustering, so we're still going to have a lot of collision. That also is not a perfect basically solution that we're looking for. So what is going to be the solution?